We will see how to design a table fan blade profile. So this is the leading edge of the blade profile, and this portion is the trailing edge, and here we have the positive angle of attack, and we are taking the 3-bladed table fan blade design. So this the top view profile may vary. Some blade may have the rounded edge on both sides, some will have. So this type of asymmetrical blade profile. So we will see how to start from this. So actually this is a complete solid model, but this we have to start as a surface design. Once surface design is ready, then only we can convert this into a solid one. That will be an easy procedure. And this is the dimensions. So overall I am taking blade profile of 150 mm radius, that is 1 feet dia blade. Then this radius I am taking 50, and this corner I am taking 10, and the center hub is 25 mm radius, and the blade length is 125, and the thickness of the hub is 30 mm, like that I have taken. So this one we will design it now. So first I am going to make this hub with a radius of 25 mm. Then we can go for this blade. Then we can come to this, the perfect the outer profile. So I am going to the wireframe and surface design. So any axis, any plane you take it. There I am drawing the circle of dia 50 mm. Then to increase the thickness, we are going to use this extrude tool, 30 mm. Then to draw the blade profile on it, I am going to use the tool helix. That is, if you expand this spline, the next tool will be the helix. This one I am going to use that. To use this helix, I need a point and axis. Okay, so first I have to create a point on it. So here there is a point tool. Select on this the bottom curve. I am going to start from some 0 point. Okay, length is 0. So somewhere the point is created. So this is my starting point to create the helix. Then select the helix tool. So point is automatically selected. And which axis we have to create the helix means about the y axis, z axis. See, helix is created, and we know the height of this cylinder. Height is 30 mm. Now by adjusting the pitch, we can create the blade. You can see the blade angle is changing. So I am taking 120 mm. So now we have created the blade profile like a line. Now we have to convert this line into a sheet as a blade. So for that I am going to use this sweep tool. Okay, so I am going to sweep that line. So here many options are there: explicit, line, circle, cone, etc. and all. So what we have is the line. So select the line. So this line is my guide curve, and with respect to this curved surface I am going to create the blade profile, and it is asking the angle. You see the angle. If you don't change this angle, just preview, you see it is in the same direction it is created along with the surface. Reference surface is 0 degree, but we need the blade which is 90 degree to this surface. So change this to 90 degree first. Let's see where it created. So the orange color shows, the orange color arrow mark shows where the surface is created. Actually it is created inside, we need it outside. Okay, so then we have to use minus 90 degree so that it will be created outside. And then these two lengths we have to create it, that is with respect to this surface on both sides, what is the required length. So length 1 is along this orange color line, so it is 125 mm. Then length 2 is within this circle how much we need it. Okay, for safer side I'm just giving 2 mm. Okay, even though it is not required inside, it may be useful in for the other operations. Finally we are going to convert everything as a solid, so you can give 2 3 also, not an issue. Simply I'm taking 2 mm. So what I have given, guide curve is this helix, reference surface is this circular surface, angle is minus 90 degree to the surface, then length of the blade 125 mm outside, 2 mm inside I have given. Now you can create, this is the blade profile for the helix we have created. Okay, so now we will create the required blade top view profile. For the first I am going to project the 3D elements. Then we can convert the sharp edges into a curved one. So here I have taken 50. First I will show blade with the both side 50 mm curvature, because many blades will be like this. It will be like a symmetrical profile about this axis. So exit. Now I am going to project this line, so extrude this line on both sides using mirrored extent like this, and then we can remove this unwanted the sharp edges. So initially we got this type of sharp edge profiles. Okay, so that we cannot directly do the edge fillet etc and all. So here we have to create another one surface, then we have to split the profile. This way only we can convert the sharp edge into a curved one. So for that we have created this profile. If you want, you can take it little bit out also. So now we will try this split tool. So this sharp edge is the element to cut. Using this element I am going to cut that. Now you can preview. So what happened, it is trying to cut inside profile, but we have to cut the other side, outside profile. So use this other side, it will be reversed. Now give OK. You see, now we have converted the sharp edges into a proper curved surface blade profile. Then we have to hide this profile, no other way. This and all we cannot delete it. Okay, the other surfaces extrude we have created, that simply we have to hide. Okay, that we cannot delete it. Simply you have to hide that. So now one blade is created. Now we will convert this both sheets into a solid. For that you have to go to mechanical design, part design. Here you can find two tools. One is the thick surface, another one is the close profile. So thick surface will convert the thin sheet into a thick solid part. So the orange color shows at which direction the solid is going to create. So I am just giving 1 mm thickness to the blade. You can see 1 mm thickness blade I have created. Then for this sheet into a hollow circular sheet into a complete solid part, I am using this close profile. Okay, simply select this surface, then OK. The complete profile will be a solid now. Again, all the reference surfaces we have to hide it, so that we will get only the solid part. And the edges, if you look, it may be sharp. So if you want, you can give the edge fillet. Maybe for this edge totally 1 mm, so this may be just 0.5 mm. Similarly in the bottom edge another one 0.5 mm. Now it is a curved one. So this way I have created one blade. Now we can go for the remaining blades also. That is simple, using this circular pattern tool. So mostly 3 bladed fans are easily available. So I am taking the 3 blades. Then the 3 blades means individually if you divide 360 degree it is 120. Then solid is current solid, automatically selected. If you want, you can select once again. Then reference element about the Z axis I have to create it. Just OK. Now you see the blade with the final blade with the 3 blade is created. So we can see this type of blade profile also, or sometime the profile will be a little different. So instead of large blend shape, here it may be like a sharp edge. Okay, like this also some fans you can see. So this height you can adjust it, depends upon the blade profile they have given. I'm just taking some 20. Then this line is not necessary now, just delete it, then exit. Now you see the profile is changed. Okay, so this type of blades also we can see in the table fan. So depends upon the top view profile that you can change it. So this is the final model. Then you can hide all those curves, planes, etc. and all. That's it. Okay, so this is the leading edge.